Good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our 8th installment of our revival of the Storm of the Month series. Today's presentation comes to you from the National Weather Service Forecast Office in Albany, New York. Presenters are Mike Evans and Christina Speciale, who will be presenting applying concepts from the Tornado Warning Improvement Project for quasi-linear convective systems to the Albany, New York CWA. And with all that being said, Christina, the floor is yours, so go ahead and take it away.
Thanks, Chris. So we're going to talk about one of the more destructive QLCSs that we've had here in the Albany region. Most of our severe weather usually occurs in the early summer months, late spring months, and this was no exception. It took place on May 15th, 2020. The QLCS actually resulted in about 150 damaging wind reports across eastern New York and western New England. It was one of the first severe weather events we had of the season, so it was a great way to kind of brush the cobwebs off from our winter season and get right into severe weather mode. What we're going to do here is actually Mike and I recently reviewed the Central Region Tornado Warning Improvement Projects training, or TWIPs, and we're going to actually apply the concepts that they taught in that lesson to this event and just seeing how it would have improved our warning decisions. So for this presentation, we'll go over the 3 ingredients method and then the confidence builders and nudgers that the TWIPs training recommends warning forecasters use to QLCSs in order to gain lead time on possible tornadoes. And then after we discuss that methodology, we're actually going to go into some null events where some of these signatures were apparent at other events outside of the May 15th case and actually did not result in a tornado. So on May 15th, 2020, very typical for the Northeast, we had an impressive shortwave trough coming out of southern Ontario, Canada, moving into the Northeast. And this event actually led to pretty impressive kinematics moving into our area where we had 50 to 70 knot winds moving aloft. And for early summer, that's actually pretty impressive. In addition to having that shortwave and strong kinematics moving into the Northeast, we actually did enter into the warm sector of a surface low. So that allowed dew points to increase. In this case, the dew points weren't terribly high. We only got into the mid to upper 50s, which for May is, it's okay. Nothing too impressive, but it was sufficient. And honestly, with these early summer events, all you need is sufficient instability. Oftentimes, when you have strong kinematics, you're off to the races, and we get some really impressive QLCSs. So in this day, looking into late afternoon hours when we were starting to destabilize, we actually had about 500 to 1,000 joules of kilogram most unstable CAPE, which again, that's sufficient. You don't need 3,000 joules that you get in the Central Plains for us in the Northeast when you have very strong kinematics in place. And looking at the dynamics, we actually had about 40 to 50 knots of effective shear, which for us, that's impressive and that's all you need. So this was a very classic high shear, low CAPE environment that was very dynamically driven, not thermodynamics. The key point here is that our dynamics and kinematics were very impressive and really what's facilitated such a strong severe weather event. So one of the concepts that the TWIPs trainings really emphasized that I learned personally from taking the training was you want to pay close attention to what's called the Mesovortex genesis region, which can be identified about 3,000 to 5,000 feet above ground level. So in our case, I actually plotted, okay, if you're looking at the half-degree tilt of all the RDAs in our region, where does the half-degree tilt actually intersect that 3,000 to 5,000 foot region? And that's where you really should be paying close attention to first get an inkling that, okay, I'm starting to see a mesovortex, and that might prompt me to try to get an early tornado warning, try to get some extra lead time by identifying a mesovortex in what's called the Mesovortex genesis region. So this map here is just kind of giving you a situational awareness of where we are. New York is on the left side of the screen, and then on the right side of the screen we have some of the New England states. So our region, we cover eastern New York and western New England. What I have plotted here is we have the 3 main radars that the Albany forecasters use. We have the ENX radar, Binghamton, and TYX. Honestly, the ENX and the TYX radar, those are our 2 big moneymakers when it comes to trying to get an early lead time on some of these tornado spin-ups on QLCSs. And coincidentally, the tornado that did occur in this case actually coincidentally occurred where the half-degree tilt intersected the 3,000 to 5,000 foot region. So we're kind of have that white circle focused on the Saratoga County region. And then just by pure coincidence, the half degrees intersects the 3,000 to 5,000 foot region. Had we been closer to the RDA, we would have the look probably on an upper tilt, maybe the 1.3 or the 2.4 tilt. But this is purely coincidence, and it worked out well because during QLCS events, you really do want to be paying close attention to your lowest scan. So that really helped out warning forecasters in this case. Briefly reviewing the 3 ingredients method, the training does say that your first step is always make sure that you satisfy the 3 ingredients method before proceeding to look at the confidence builders and nudgers. So what does that mean? You first want to identify that your QLCS is either balanced or shear dominant. That's the region of the QLCS that you want to make sure you're focusing on. Step 2 is you want to make sure that your 0 to 3 kilometer line normal bulk shear magnitude is greater than or equal to 30 knots. That can be a little challenging for some forecasters to kind of grasp. I know me personally, it took me a while to kind of understand how on the warning desk am I doing some trigonometry, which, you know, you're really not doing trig kind of in your head, but that could be a little challenging of a step. But with practice, I think most forecasters kind of get the hang of how to satisfy that second step. And then third and last, you want to make sure that you're looking at that the portion of the QLCS does have an enhanced outflow or a rear inflow jet. So those are the 3 steps that you really want to make sure you satisfy before moving on to kind of looking for the confidence builders and nudger step. And here's a listing of what the training does identify as confidence builders and nudgers. So assuming you've satisfied the 3 ingredients method, your next step is to try to pinpoint some of these signatures on your QLCS. And again, these signatures are probably most easily identified in the lowest tilt. So paying close attention to the half-degree tilt is important when trying to figure out if any of these signatures are present. The training does say that you want to find at least 3 confidence builders before you have enough confidence to actually go ahead and try to get an early lead time on a possible tornado. So should you meet the 3 ingredients method and then identify at least 3 of these signatures, in theory, that should be enough of kind of confidence to go, all right, let me try to see if I can issue an early, get some lead time on a tornado warning and see if I can get some lead time, because many of us in the Northeast know that these quick spin-ups along QLCSs, I mean, those happen so fast, and to get lead time on them is, you know, any couple of minutes that you can get, the better. So first and foremost, let's look at the sounding and a hodograph to kind of get some situational awareness of what was taking place on this day. You can see just looking at the boundary layer and looking at the column in general, this day featured very strong winds throughout the column. This sounding was from the NAM, valid for Albany, at 21Z on May 15th. This is the 12 UTC run of the NAM. Really, so you can see strong winds throughout the column, and you can also see directional shear, especially in the low levels. So combined with strong kinematics and some directional shear in the low levels, that resulted in having 0 to 3 kilometer shear vector about 45 knots from about 280 degrees. So for us, 45 knots and 0 to 3 kilometer shear, that's pretty impressive and definitely keeps our attention high for a possible QLCS. So here we are, again, focusing in on Saratoga County, New York, which is where the tornado took place. This is about a half an hour ahead of when the tornado actually occurred. At this point in time, at 21:33 UTC, the Albany forecasters, we were in full-on warning mode. We had already been watching this portion of the QLCS for, I would say, at least probably 45 minutes at this point. At this point in time, we were really paying close attention because we had been getting numerous strong wind reports, damaging wind reports. It was leading to a lot of damage as it was heading into Saratoga County. And also for us, Saratoga County is one of our more populated counties, so we were really paying close attention at this point in time. So again, first step of the 3 ingredients method is you want to identify which portion of your QLCS is shear dominant or balanced. So for us, the training actually says that it's easiest to identify where your updraft convergence zone region is by actually looking at spectrum width, which for me, that was something new to learn. I've always just looked at storm relative velocity, but spectrum width I have found is much, much easier and much quicker. And when you're looking at spectrum width, you do want to try to find areas with the maximum values, and that is the easiest way to identify your updraft convergence zone region. Here on the bottom left screen, I have the spectrum width, half degrees, outlined, and we have in white the position of the updraft convergence zone region. Then if you superimpose that on the reflectivity, again, the top left panel, where you have the half-degree reflectivity, you can clearly see that the bottom portion of the QLCS near Mayfield and Gloversville is slightly cold pool dominant, where, again, the training is telling you, okay, that might not be a region you want to pay attention to because that one really is just primarily going to be damaging winds, not too favorable for a tornado spin up. However, as you head north on the segment towards Northville, really can see that it transitions pretty quickly to becoming balanced and even shear dominant. So the training says that your focus should be on the northern segment of this QLCS. Then again, we've already looked at our hodograph, and we've seen that our 0.3 kilometer bulk shear vector is about 45 knots coming from 280 degrees. And if you put that in position to the QLCS portion that is shear dominant and balanced, there is an angle. There is a difference, meaning that it's not parallel to your updraft convergence on region, which is really important. If you do have an angle difference between the 0.3 kilometer bulk shear vector and the position of your balanced and shear dominant region, that angle is important. And that actually shows you that the line normal shear vector is actually greater than or equal to 30 knots. In this case, since the magnitude of our 0.3 kilometer bulk shear vector is already 45 degrees, having an angle in this case about 40-degree difference, that was definitely enough to satisfy the 30-knot requirement. So step 2 of the 3D gradient method is checked off. Then finally, looking at storm relative velocity, we do see that there is a bow or an enhanced surge in the line, and that satisfies step 3. So 3D gradient method is now satisfied, and we can move on to looking at confidence filters and nudgers to see if any of those are in place. So moving ahead in time, we can see that at 2139 UTC, we do have a line break, and that is one of the signatures on the confidence builders and nudgers. That kind of suggests that your rear inflow jet is so strong that it's actually broken through the line. So that's a really important signature to identify, and we have one of them on the list. Continuing to move in time, we notice that we have a pronounced reflectivity drop as the line is approaching the Northway, which is a pretty major interstate here in upstate New York. So that's really another important signature to point out. And then also we notice we have some boundary ingestion, and that often is something that you want to keep a close eye on. Then we also notice, looking at storm relative motion, we are starting to see some rotation in the northern segment of the line. So we have a reflectivity drop, we have a line surge, we have boundary ingestion. That's 3 signatures already checked off on the list for confidence builders and nudgers. So at this point in time, had you been following this training and this methodology, you might think to yourself, all right, now I might have enough confidence to do severe thunderstorm warning with a tornado tag, or you maybe have enough confidence to even go tornado warning, given that you are already starting to see rotation, and that rotation is in the Mesovortex genesis region. So that might even give you enough confidence to go tornado warning. So at 2159 UTC, this scan is very important. This is the scan actually we want to spend a little time looking at. On this portion, we have a zoomed in view of the line as it's approaching the Northway or central Saratoga County. We can see that we have clear paired rear and front inflow notches, which for us in the Northeast is something we often see on QLCSs. In addition, when we superimpose and look at the updraft convergence zone region once again, again using spectrum width to identify it, we can see that the bottom portion of the QLCS has become even more cold flow dominant, while the northern portion, again, has transitioned to becoming balanced and shear dominant. So again, our focus remains on the northern segment of this line. Then if we look again at the northern segment of the line, we also see that there's an entry point, an updraft convergence zone entry point, which is another signature on the confidence builders list. And then lastly, our enhanced surge is still in place. So we've identified even additional signatures on the confidence builder list that again might prompt you to go tornado warning. So if we're looking at different storm relative motion tilts, the 1.3 degree tilt, while it does intersect 6,300 feet, which technically is a little higher than the Mesovortex genesis region, kind of splitting hairs, it might be enough because you do see a couplet there, and you could argue that's probably the Mesovortex. Looking down at the 0.9 degree tilt, we do see that our rotation is still in place, although not as apparent as on the 1.3 degree tilt. And then looking at the half degree tilt, it's kind of gone. We really don't see much in place. But again, you're intersecting at 3,000 feet, so maybe you're not intersecting the Mesovortex anymore, you've kind of gone below it. And again, you're 3,000 feet, so maybe there's a couplet lower in tilt. Maybe it's at 1,000 feet or 2,000 feet, and you're just overshooting it. But at this point, you probably are seeing a Mesovortex, and that could prompt you to go tornado warning. And had you gone tornado warning, you'd have been right, because there was a tornado here in Wilton, New York. It was an EF1. It led to considerable damage. We got reports left and right. The phones were ringing off the hook. letting us know that there was considerable damage in the town of Wilton. It's a pretty populated area in Saratoga County. It only lasted 2 minutes, but it did end up going almost 2 miles, and it led to considerable damage. So with that, I'm going to pass it on to Mike, and he's going to talk about some of the tornado null cases.
Okay, thanks, Christina. Yeah, so I'm going to talk about what this line looked like then as it continued to progress eastward. I'm going to focus on the area about 15 to 30 minutes after the tornado occurred. So this is what the line looked like as it continued to move eastward across eastern New York. You can see it's still certainly a very impressive looking QLCS with a bow echo. And if you look at the SRM with this, we don't have the greatest angle to look at SRM in this case as the storm was moving kind of perpendicular to the radial, but you can still see kind of a wind signature there with a broad rotation moving east across eastern New York. So again, we'll take another quick look at the three ingredients just to make sure that we're still satisfying the three ingredients at 2220. So again, that's about a half hour later than the times that Christina was looking at. On the left is a plot that shows the 50-knot 0 to 3 kilometer shear over the central part of the line. You can see it's perpendicular to the line of storms. So definitely you're satisfying the 30 knots of shear perpendicular to the line. Up in this part right here where the line kind of bends back from southeast to northwest, the component of the shear is about 30 to 35 knots. So you're still realizing then at least 30 knot 0 to 3 kilometer shear parallel to the storm. You certainly have a bow or a surge in this case. And if you look in the upper right, you can see that the storm had become very outflow dominant over the southern part of the storm. But there were, it looks like, a couple of entry points in the updraft convergence zone further north. So you've got an area of balanced or shear dominant flow here in the northern part of the storm. So it looks like the three ingredients are being satisfied here. So looking at 2220, again, this is about a half hour after Christina showed her stuff. A couple of things that we can see here, certainly descending rear inflow jet with a reflectivity drop coming into the backside of the storm. You've got the paired front rear inflow notches here and here. Some of the confidence builders are being met here. You certainly have an enhanced surge. This is the reflectivity at 2213 UTC. And then again at 2220 UTC, you can see a very strong surge off to the east-northeast at that time. So enhanced surge is being realized there. Again, if you look at the updraft convergence zone and you kind of plot it out with spectrum width, and again, sometimes you can do this very well with storm relative velocity or velocity 2, but in this case, we don't really have the greatest angle to get a good look at the velocity. So we use spectrum width, and you can see the storm had become very outflow dominant in the southern part of the storm, but in the central and northern part, there's a couple entry points here and up in here. So we certainly, we have this updraft convergence zone entry inflection point confidence builder being matched as well. And then the next slide shows that there were these reflectivity elements that were oriented kind of perpendicular to the main line. We don't know for sure, but we suspect that those probably were laying down some kind of differential heating boundaries that the QLCS was intersecting as it moved east. So it does seem likely that there was some kind of boundary ingestion going on at this time. And then as far as rotation, there's a broad area of rotation that you can see on the SRM associated with sort of the midpoint of the QLCS. There was this kind of interesting looking enhanced area or of rotation going on in this part of the line. It looked very small but intense. It didn't have a lot of vertical continuity to it or temporal continuity. And it also didn't look like it was quite in exactly the right part of the line. It was kind of down the line a little bit from the main entry point and front inflow notch. So I wasn't too sure if we were getting a really good look at some kind of a low-level spin up here, but certainly there's this broad rotation that we're seeing at this time. And then another nudger is the 0 to 3 kilometer cape, greater than 40 joules per kilogram. This is a NAM forecast, a 0 to 3 kilometer cape at Albany, and you can see there was an extended period of time where the 0 to 3 kilometer cape was well over 50 joules per kilogram. So the tornado warning for this line was issued at 2216 UTC, and you can see off to the right here, lots of wind reports, but no tornado. So you can see this is quite a rural area in here. To get that many wind reports in that rural of an area is pretty impressive. So assuming that this was some kind of a null case where we didn't get a tornado, despite the fact that we had these confidence builders, maybe you want to look as to how common that is to see these confidence builders yet not get a tornado. So the graph on the left here shows some results from a real short study that I did. I looked at 5 cases. They were for QLCSs. We issued tornado warnings, and no tornado occurred. So these were null cases here in the upper left. Each of these dots indicate a case, and you can see the number of confidence builders at the time of tornado warning issuance was 3 or greater for all 5 null cases, and the number of confidence builders at time T-1, which is approximately 5 to 10 minutes before the time of tornado warning issuance, was also 3 or greater. So what this is showing is that you do get these confidence builders and nudgers sometimes in these null cases. I compared that to QLCS tornado cases. Again, just took a very small sample, looked at 5, and the number of confidence builders that were yes at the time of tornado touchdown were all 5 or greater. The number of confidence builders that were yes at T-1, again 5 to 10 minutes before tornado touchdown, were 2 or greater, mostly 4 or greater. So the bottom line of what these charts are telling us is that you do see these confidence builders and nudgers, certainly for tornado cases, but also for null cases in our area. And then this is just a quick attempt to try to get an idea of which confidence builder and which nudgers might discriminate best between tornadic cases versus null cases. I circled a few that showed maybe some ability to do that, but again, it's based on just a very small number of cases. So boundary ingestion, I found that the tornado cases, you had a boundary ingestion more often than you had for the null cases. A contracting vortex occurred more often for the tornado versus null. A tight vortex occurred more often with the tornado versus null. Cell mergers along the squall line occurred more often with tornado than the nulls. And a history of tornadoes occurred more often with the tornado cases than with the nulls. So again, this is obviously a very small sample size, but interesting to note that it looks like maybe some of these confidence builders and nudgers for the very small sample size may have been a little bit more useful than others. Now, one thing that might be going on in our area is that with some cases that we're calling null cases might actually be cases where there were tornadoes. The shot on the right is a shot of what the southern Adirondacks looks like, about 60 miles northwest of Albany. The shot on the left is southern Vermont, about 60 miles to the northeast of Albany. So bottom line here, these areas are very rural. It would be very easy for a small tornado to occur and not be reported, not be surveyed. And tornado warnings for these areas might come out as null warnings, but they may or may not be in reality. So last slide here, just the takeaway points. I did find that when I was going through the confidence builders and nudgers, trying to figure out how many yeses there were for these cases, there is some subjectivity to that process, right? In other words, sometimes you might have a small, subtle looking rear inflow notch. Do you call that a rear inflow notch or not if they're kind of small or subtle? So there is some subjectivity to this. It's not as easy as just obvious yes or obvious no. It does look like several confidence builders and nudgers were identified for both tornadic and non-tornadic cases. Confidence builders appeared to increase in number at the time of tornado touchdown, again, based on a very small sample of cases. And final point is that vast rural areas in eastern New York and western New England likely do affect the verification of small tornadoes in our area. And with that, I think we're finished with our presentation. We'll take any questions.
All right, I'll go ahead and thank Mike and Christina for this great presentation. And thank you all for participating here. And thank you again to Mike and Christina. And we will see you all next time.